Okay, so today we're going to look at light emitting output devices. Now you're very familiar with lights and light bulbs and lamps. They're just things that you've been using in electricity one and two, and they're just your normal sort of bulbs that you find plugged into your bulb sockets at home. We also have light emitting diodes, LEDs, which are being used more and more regularly now in lots of different formats, and also 7-segment displays, which use LEDs to display something. So the LED. LEDs are in many ways better than light bulbs because they're more efficient. So we know that the energy change in a light bulb is electrical to light and heat, but in an LED it's just electrical to light. There's very little heat produced, which means that more of the energy can go into useful output energy as light. So they're usually used as indicator lights in electronic systems, so they show that they're on or off. They're very small and they don't produce waste heat. But they only allow current to flow in one direction. And we know that now that people using LEDs and TVs and things like that, so they are becoming more and more used. So LEDs they only allow electricity to flow one way. So LEDs have to be connected in a certain way. And the way that they have to be connected is, the way that I remember it is they point towards the negative. So this is kind of, I suppose you could say that looks a bit like an arrow pointing in that direction. So it's pointing towards the negative. And if it's set up like that, then the LED will turn on. However, if it's not pointing towards the negative, so you can see this one, it's sort of like a kind of an arrow pointing that direction, and that is the wrong way around. So that will not turn on. It will not light unless it is connected the correct way around. And you can see in these diagrams that each of the LEDs come with a resistor. Okay, so they come with a protection resistor there. And they have to come with a protection resistor for those reasons, but to protect the LED, because they only allow a certain amount of current through them. Otherwise, they will have issues and they might break. So, in order to avoid too large a current flowing through the LED and causing it to overheat and burn out, a protection resistor is used, and it has to be in series with the LED. The value of resistor required to protect an LED can be calculated by considering it like a potential divider. So we're basically using V equals IR to work it out. Normally, a typical LED has a maximum rating of 2 volts and 10 milliamps. So, an example here, and for LED questions, they're all the same. You do the same steps every time for an LED question. So it says, calculate the value of protection resistor required when an LED rated at 2 volts, so that's how many volts can go through it, and 10 milliamps, that's how many amps can go through it, is connected to a 5-volt supply. Okay, so we know that 10 milliamps, we need 10 milliamps, and we need it to be 2 volts. So first of all, what we want to do is we want to work out what the voltage across the resistor is. This voltage here. We know that VR, we know that the resistor and the LED are in series, so they will share the voltage. So if the LED has 2 volts across it, then the resistor must have 5 minus 2 volts across it, so 3 volts. So 2 plus 3 equals 5. Okay, they share the supply voltage. We know we're told that the current is 10 milliamps, but you need to remember with units, you need to be careful, change it into amps. So therefore, the resistance of the resistor is the voltage across the resistor divided by the current through it. Current in series circuit is the same at all points, so the current is just the current. So it's that 3 divided by 0.01. That comes to, obviously, 300 ohms. Okay, so you've done these types of questions before, like find the resistance of this resistor, but there just might not have been an LED in it. So let's do example 2 together, then I'll get you guys to have a go. So calculate the value of protection resistor required when an LED rated at 1.8 volts, 12 milliamps is connected to a 12-volt supply. Now the first thing really to do that will help you is draw a diagram. So it's 12-volt supply, and we've got a resistor and an LED in series. Okay, it's 12 milliamps going around the circuit. It's a series circuit, so it's the same at all points. And we know that the LED is 1.8 volts. Okay, so we want to know what the voltage across the resistor is first of all. We'll call that VR. And we also want to know the value of the resistor. So we do the same kind of thing, exact same steps as above. So we first of all want to find the voltage across the resistor, which is the total voltage minus the voltage across the LED. So 12 minus 1.8, and that is 10.2. We know the current is 12 milliamps, but we're best changing that into amps straight away. So 0.012 amps. And then we find the resistance of the resistor by taking the voltage across the resistor and dividing it by the current. So that's 10.2 divided by 0.012, and that comes to 850 ohms. Okay, so you can see it's the same steps each time. These ones are quite repetitive, but that's good in a way because they're really easy to answer. Okay, so what I'd like you to do is have a go at a couple of questions on this, and then we'll move on to the next